June 8, 1944. Dawn creeps over the beach at Arromanches, 2 days after the bloodiest amphibious landing in history. Engineers stand before a deadline none of them believe is achievable. The Allied invasion of Europe is already behind schedule. Without a working harbor, the entire D-Day operation could collapse within weeks. There's just one problem. The nearest usable port is 40 miles away, in German hands. What happens over the next few days defies every rule of military logic. In just 6 days, military engineers will build the largest artificial harbor the world has ever seen. 2 million tons of floating concrete, positioned under enemy fire, in one of the most unpredictable seas on Earth. This story isn't about who won the battle. It's about how an engineering problem was solved that military experts had declared impossible. To understand why the Allies were forced to build a harbor from nothing, we need to go back 18 months, to a beach where everything first went wrong. August 19, 1942. Operation Jubilee. The British-Canadian raid on Dieppe ends in catastrophe. Of 6,000 troops who land on the French beaches that morning, 3,600 are dead or captured, 30 tanks destroyed, 106 aircraft shot down. The assault never even reaches the town itself. That afternoon, British Naval Commander John Hughes Hallett sails back across the English Channel on his vessel. He has just witnessed a massacre. Every military doctrine says the same thing. To supply an invasion, you need a captured port. But Dieppe proves something chilling. The Germans have turned every French harbor into a fortress. Concrete bunkers, artillery positions, machine gun nests covering every approach. According to witness accounts from combined operations records, Hughes Hallett turns to a fellow officer and says something that sounds, at first, absurd. If we can't capture a port, we'll have to take one with us. Ports take years to build. Deep water foundations, massive breakwaters, crane systems, piers stretching hundreds of feet into the sea. How do you just take a harbor with you? But Winston Churchill sees genius in the idea. 3 months before Dieppe, on May 30th, 1942, he'd already circulated a secret memo titled Piers for Use on Beaches. In it, he writes, they must float up and down with the tide. The anchor problem must be solved. Let me have the best solution worked out. Don't argue the difficulties. They will argue for themselves. Here's the scale of the challenge the planners were facing. The proposed invasion of Normandy is meant to put 150,000 troops ashore on D-Day. But that's just the beginning. To break through Hitler's Atlantic Wall and push into occupied Europe, the Allies will need 2 million more soldiers, 500,000 vehicles, 4 million tons of supplies, all within the first 100 days. Every single ton has to come through a harbor. But the Normandy coast has no natural harbors. The nearest one, Cherbourg, sits 30 miles west, fortified by German troops who will destroy the facilities before they surrender. Intelligence estimates it will take months to repair after capture. The math is brutal. Without harbor facilities, the invasion stalls. Supplies pile up on open beaches. Vehicles bog down in sand. Reinforcements can't reach the front lines, and the Germans counterattack a stranded army. Planners calculate they need harbor capacity for 12,000 tons of cargo and 2,500 vehicles every single day. Not in calm weather, in every weather. Atlantic storms, 26-foot tides, waves that can flip a landing craft like a toy. And it all has to be operational within 3 weeks of landing. This problem lands on the desk of a committee of civil engineers in August 1943, just 10 months before the invasion. Chairman, Colin R. White. Location of the first meeting: the Institution of Civil Engineers in London, not a military command center, a civilian engineering society. White's team faces technical challenges that would make most engineers walk away. The harbor has to be built in Britain, taken apart, towed across 60 miles of open ocean, then reassembled on enemy beaches, under artillery fire. Every component has to float for transport, but sink on command to create stable foundations. Oh, and one more thing. The entire project is classified top secret. The 200,000 workers building the components aren't allowed to know what they're actually making. The solution the engineers land on is codenamed Mulberry. 2 complete artificial harbors, each the size of Dover. A natural harbor needs 3 things: a breakwater to stop the waves, piers for ships to dock at, and roadways to move the cargo ashore. The Mulberry team has to invent all 3 from scratch, using materials that can survive a 60-mile ocean crossing. First, the breakwater, the first line of defense against the Atlantic. The team floats some wild ideas, including a wall of air bubbles released from underwater pipes. Physics kills that plan fast. Instead, they design 3 layers of protection. The outer ring, floating steel breakwaters codenamed bombardons. Each unit measures 200 feet long and 25 feet high. Steel and rubberized canvas, shaped like giant plus signs. 24 units linked together form a mile-long wave barrier. The middle ring, scuttled ships, codenamed corncobs. The Royal Navy assembles 61 vessels, old freighters, obsolete warships, including the French battleship Courbet, launched in 1911. These ships will sail to Normandy under their own power, position themselves in precise formations, and then deliberately flood and sink, creating permanent breakwaters. The inner ring, the Phoenix caissons. This is where engineering turns into art. The Phoenix caissons are hollow concrete boxes. The largest weigh 6,000 tons, stand 60 feet tall, and run 200 feet long. Essentially floating buildings. Each one contains multiple chambers that can be flooded to sink it, or pumped dry to float it. And here's the clever part. The Phoenix units are built at shipyards scattered across Britain, floated into position, and then deliberately sunk off the English coast before D-Day even begins. That hides them from German reconnaissance aircraft. When the moment comes, they'll be refloated by pumping the chambers dry, towed to France, and sunk again in precisely calculated positions to form the harbor's breakwater. But testing turns up a critical problem. One Phoenix caisson runs aground near Southampton. Engineers try to refloat it using standard pumps. Pumps designed to move sewage horizontally through pipes. They can't generate enough vertical lift to raise water 60 feet up and out of the chambers. The whole mission nearly fails before it even starts. Enter Captain Edward Ellsberg, a U.S. Navy salvage expert. He reviews the British plans and delivers a blunt verdict. The technique won't work. Churchill himself steps in, pulls the task away from the Royal Engineers, hands it to the Royal Navy. Ellsberg tracks down every salvage barge in Britain, assembles heavy-duty pumps capable of real vertical lift, and redesigns the entire refloating operation from scratch. This one fix saves the invasion. Now, the piers. They need to handle 2,000-ton cargo ships in waters where the tide rises and falls 26 feet, twice a day. Static piers won't work. They'd be underwater half the time. Major Alan Beckett of the Royal Engineers designs the solution. Floating pier heads, codenamed spuds. Each one is a steel pontoon with 4 massive legs. The legs rest on the seabed while the pier itself floats freely, rising and falling with the tide. Ships can dock at any hour. Connecting the spuds to shore are floating roadways called whales, bridge sections mounted on pontoons called beetles. Each whale segment spans 80 feet. The segments are linked by flexible joints that twist and bend with the waves without breaking. But what holds all of this in place against the current and the storms? Alan Beckett invents a new anchor, the kite anchor. Traditional ship anchors rely on sheer weight. The kite anchor uses a specially shaped blade that digs deeper into the seabed the harder you pull on it. Its holding power is so extreme that after the war, most kite anchors couldn't even be recovered. They're still buried in the seabed off Normandy today, but the Royal Navy doesn't believe Beckett's claims about its holding power. They refuse to use kite anchors for the Bombardon floating breakwaters, a decision that will prove catastrophic. Châteauneuf, September 4th, 1943. The combined chiefs of staff give the order: begin construction immediately. The Mulberry Harbors must be ready by May 1st, 1944. 8 months to build 2 complete artificial harbors from nothing. 200,000 workers mobilize at sites across Britain: London, Tilbury, Woolwich, Southampton, Portsmouth, Middlesbrough. The operation alone requires 147 Phoenix caissons. Each one needs more than 6,000 tons of reinforced concrete and 350 tons of rebar. Total materials for both Mulberry Harbors: 2 million tons of concrete and steel. More construction than some countries complete in a decade. Major contractors bid for the work: Balfour Beatty, Costain, John Laying, Taylor Woodrow. 27 contractors build Phoenix caissons at 35 different sites simultaneously. Hundreds of smaller firms fabricate whales, beetles, spuds, and anchoring systems. Security is absolute. Workers receive component specifications with no context. Welders build steel frames. Concrete crews pour caissons. Nobody knows they're building a harbor. Rumors spread that the massive concrete structures are post-war building material or floating fuel tanks. A senior official from Whitehall visits construction sites in person to reassure the workers their labor is vital to the war effort, without ever revealing what they're actually making. German intelligence photographs the British ports. They spot the concrete structures. In May 1944, the Nazi propaganda broadcaster known as Lord Haw Haw addresses British radio listeners directly. He tells them the Germans know exactly what those caissons are for, that they're meant to be sunk offshore when the attack comes, and that the Germans will save them the trouble and sink them first. The Germans believe the structures are fuel storage tanks. They miss the true purpose entirely. Meanwhile, the construction deadline is crushing. Despite tens of thousands of laborers, the work barely finishes in time. The Phoenix caissons need huge launching basins, dug out of the riverbanks along the Thames and the Medway. Each caisson has to be built, floated out, sunk in a designated holding area, then refloated when it's needed. The Royal Navy assembles 200 tugboats for the towing operations. Each one gets a large M painted on its funnel. The crews take fierce pride in the mark. They know they're part of something historic, even if they don't know what. Coordinating all of it is a nightmare. Every Phoenix caisson needs 2 tugs for the channel crossing. Bombardons have to be assembled in exact sequence. Whale roadway segments require precise manufacturing tolerances, or they simply won't link together. The spud pier heads need hydraulic systems capable of mechanically precise lifting and lowering. One miscalculation, one failed component, and the entire operation collapses. Testing exposes the cracks. A trial assembly at Wigtown Bay in Scotland, chosen because its tides match Normandy's, reveals weaknesses in the early design. During a storm, some pontoon sections wash away. Floating roadways collapse under the weight of a 7-ton truck. Engineers redesign on the fly. By June 1st, 1944, the components are finally ready. Thousands of sections wait at assembly points. Portland, Poole, Plymouth, Chelsea, Dungeness. Some sites are deliberately placed within range of German long-range artillery at Calais, part of a deception meant to convince the Germans the invasion will target that region instead. Then the weather turns. On June 4th, Eisenhower postpones the invasion 24 hours because of storms. The Mulberry components sit exposed, swaying in the wind. Engineers worry the structures will break apart before they even cross the channel. On June 5th, Eisenhower gives the final order. Operation Overlord begins at dawn tomorrow. The Mulberry convoy prepares to sail. June 6th, 1944, 12:30 p.m. While American troops are still fighting their way off Omaha Beach, the first Mulberry convoy appears on the horizon. 45 block ships, the Corn Cobs, arrive first. These obsolete vessels steam into position under their own power. Engineers aboard each ship follow precise coordinates. They open the sea valves. The compartments flood. Within hours, 61 ships have been deliberately sunk in arcing lines off Omaha and Arromanches. The scuttled ships create instant sheltered water, the gooseberries. Landing craft can now unload behind the protection of the hulks, while construction continues around them. On June 7th, the Phoenix convoys begin arriving. Each convoy consists of 8 Phoenix caissons, 8 bombardons, 4 pier heads, 10 whale roadways, and support vessels. Towed by the tug fleet at 4.5 knots, faster than the planned 3.5, to cut down turnaround time. Planners had expected to lose 20 to 25% of the components during the crossing. The actual losses? Less than 5%. Half a floating roadway sinks. One caisson runs aground. Otherwise, these massive structures survive 60 miles of open ocean. Now comes the hardest part: assembly, under fire. German artillery on the bluffs above the beaches can still reach the construction zones. The Luftwaffe attempts night raids. Engineers work around the clock, positioning multi-thousand-ton concrete structures with precision measured in feet, not yards. The first Phoenix caisson has to be sunk at dawn on June 8th at Arromanches. The operation demands perfect timing. Tugs position the caisson. Engineers open the flood valves. The Phoenix settles, but too slowly. The tide turns mid-sink, swinging the massive structure at a right angle to its planned position. Disaster? No. The misplaced Phoenix accidentally creates an extra windbreak from the west, one that actually improves the harbor's overall design. At Omaha Beach, positioning goes faster. American engineers sink their first Phoenix exactly where it's supposed to go. By June 11th, just 5 days after D-Day, the Gooseberry breakwaters are complete. Phoenix caissons are being positioned at a rate of 15 per day. By June 15th, 2 piers and 4 pier heads are operational at Omaha. British engineers at Arromanches have sunk 115 Phoenix caissons in a 5-mile arc. The harbor encloses 2 square miles, the same size as Dover. Anti-aircraft guns are mounted on the Phoenix superstructures and the hulls of the block ships. 2 American anti-aircraft battalions take up position on the concrete structures, floating defense platforms. From June 15th to 18th, Mulberry A at Omaha lands nearly 19,000 troops a day. Mulberry B at Arromanches lands close to 16,000. Both harbors are moving 2,000 vehicles and 25,000 tons of stores every 24 hours. The impossible has been achieved: 2 fully functional artificial harbors built in 6 days, Then nature intervenes. June 18, 1944. Evening. The weather at Omaha Beach is perfect. Calm seas, clear skies. Mulberry A has just officially opened for operations. Supply ships line up to dock at the piers. At midnight, the barometer starts to fall. By 3 a.m. on June 19th, wind speeds hit 30 knots. 8-foot breakers roll in from the northeast. It's the worst channel storm in 40 years. For 72 hours, the artificial harbors battle forces they were never designed to withstand. The Mulberries were engineered for summer conditions. Moderate winds, manageable swells. This is a winter gale. In June, the Bombardon floating breakwaters are rated for winds up to 30 knots. The storm blows past that within hours. The Bombardons, anchored with traditional ship anchors instead of Beckett's kite anchors, start tearing loose. Without kite anchors digging deeper under stress, the Bombardons drift. Several break their moorings and crash into the Phoenix caissons. Concrete cracks under the impact. Water floods the internal chambers. Phoenix units, designed to be sunk under controlled conditions, are now failing catastrophically. At Arromanches, Lieutenant Colonel Raymond May orders emergency procedures. Moorings are doubled. Ships outside the harbor move into deeper water. 500 landing craft shelter inside Mulberry B, behind the Phoenix line. Royal Engineer bridge parties work 40-hour shifts without sleep, fighting to save the piers as waves wash over the pontoons. Whale roadway segments twist under the strain. Anchors drag. British tugboat crews battle to corral landing craft that have broken loose and are smashing into the harbor structures. The British harbor holds, barely. At Omaha, Mulberry A is being destroyed. The American harbor faces larger waves. Later scientific analysis confirms the wave heights at Omaha exceeded those at Arromanches. Combined with the American decision to assemble their harbor on a faster timeline, meaning some Phoenix caissons weren't as securely anchored, the structures fail. 21 of the 28 Phoenix caissons are completely destroyed. By a combination of wave action, scouring of the seabed foundations, internal water pressure from flooding, and bombardons smashing into them, the piers collapse, roadways wash away. By June 22nd, when the storm finally dies down, Mulberry A is gone. General Omar Bradley walks the beach at first light on June 23rd. He later writes that he was appalled by the devastation, that it far exceeded what he'd seen on D-Day itself. Landing craft are stacked 3 deep in the sand, wrecked equipment everywhere, vehicles crushed under collapsed pier segments. The scene looks like the aftermath of a battle, except this time the enemy was the weather. At Arromanches, Lieutenant Colonel Raymond May walks the piers of Mulberry B at dawn. He salutes the exhausted engineers who greet him. He says nothing, but they understand. They've saved the harbor. The damage assessment: 6 Phoenix caissons lost, piers damaged but repairable. The breakwater holds. Even on the worst day of the storm, British engineers managed to move 800 tons of supplies through Port Winston, the nickname for Mulberry B. Over the full 4-day storm, 7,000 tons passed through the battered harbor. The engineers make a critical call. Mulberry A at Omaha is beyond repair, but its components aren't scrap. Salvage crews pull usable Phoenix caissons, whale sections, and pier equipment out of the wreckage. Everything that can float gets towed to Arromanches. Mulberry B is reinforced with American components. Specially strengthened caissons are added to the breakwater. The harbor that was designed to last 90 days will operate for 10 months. The logistics are staggering. At peak efficiency, Port Winston handles 40,000 tons a day. That's the equivalent of 20,000 jeeps, 800 tanks, and 40 million rifle rounds every 24 hours. By October 1944, with the Allied armies long since broken out of Normandy and advancing across France, Port Winston has landed 2.5 million soldiers, 500,000 vehicles, 4 million tons of supplies. 25% of all Allied supplies reach France through Arromanches, 15% of vehicles, 20% of reinforcements. This one harbor, built in 6 days, battered by storms, operating far beyond its intended lifespan, becomes the logistical backbone of the liberation of Western Europe. At Omaha Beach, the Americans adapt. Without working piers, they land supplies directly onto the beach, sheltered by the Gooseberry Breakwater. Amphibious cargo trucks, the DUKWs, shuttle back and forth between ships and shore. Smaller ports at Port-en-Bessin and Isigny fill in the gaps. By November 1944, the Allies capture the port of Antwerp. Finally, a deep-water harbor with permanent facilities. Port Winston is officially decommissioned on November 19, 1944. The Royal Engineers dismantle what they can. Whale bridge segments are salvaged and reused to repair bombed-out bridges across France, Belgium, and the Netherlands. Others are shipped to Cameroon in 1954 to help build infrastructure there. In the 1960s, 3 whale segments are repurposed at Ford's plant in Dagenham, England. Cars roll straight off the assembly line and onto ships, over components built for D-Day. But the Phoenix caissons, those stay put. Too massive to move, most of them remain exactly where they were sunk 80 years later. Today, you can walk the beach at Arromanches and see the remains of Mulberry Bay offshore. Dozens of Phoenix caissons still break the waves, exactly as they did in June 1944. General Eisenhower called Mulberry one of the most inventive logistical undertakings of the war. General Bradley described it as an act of engineering brilliance that saved the invasion. Albert Speer, Hitler's Minister of Armaments, admitted after the war that the Mulberry Harbors had rendered the entire Atlantic Wall irrelevant. The Nazis had built thousands of bunkers, laid millions of mines, fortified every port, all of it based on a single assumption that the Allies would be forced to capture a harbor. Instead, the Allies brought their own. The engineering lessons are still felt today. The Phoenix caissons pioneered techniques now used in offshore oil platforms, massive floating structures that can be precisely positioned, then sunk to create stable foundations. Modern artificial islands in Dubai and Singapore use evolved versions of Mulberry technology. The whale pontoon bridges introduced flexible roadway design, segments that move independently but function as a single unit. Modern military mobile bridges trace their lineage directly back to Alan Beckett's D-Day design, and the kite anchor is still considered one of the most effective deep-holding anchor designs ever invented. The anchors that held Port Winston through the June storm demonstrated a holding power that modern marine engineers still study. But perhaps the most important lesson is this: the Mulberry Harbors succeeded because engineers were handed an impossible problem and refused to accept no as an answer. 200,000 workers built components they didn't understand. Tugboat crews towed structures across 60 miles of hostile water. Royal Engineers assembled a harbor under enemy fire, and when a 72-hour storm destroyed half the project, they rebuilt it with salvaged parts and kept going. The Mulberry Harbors weren't perfect. Mulberry A was destroyed. Components failed. Designs needed mid-operation fixes. But they worked long enough and well enough to change the course of history. 6 days to build a harbor, 10 months of continuous operation, 2.5 million soldiers landed, 4 million tons of supplies delivered, all of it out of floating concrete. And an idea that at first sounded absurd. If we can't capture a port, we'll have to take one with us. On that same beach at Arromanches, where dawn broke over exhausted engineers on the morning of June 8, 1944, the Phoenix caissons still sit in the water. No marble monument, no museum behind glass, just concrete that has held against the waves for 80 years. The same way it did on the morning an impossible problem suddenly found its solution. Sometimes the greatest weapon in a war isn't a ship or a bomb. It's the refusal to accept no.